Bonjour, aujourd'hui on va vous faire Logic Gate pour la grade de 10. Alors ce que nous trouvons en premier lieu, c'est qu'il nous fait une introduction to Logic Gate, Cinnamon Circuits. Alors, nous prenons un circuit, nous analysons, nous faisons ce truth table. Ensuite, nous déterminons the symbol and we have determined the expression, which is, for this case, is x is equal to a plus b. This is the Boolean expression, and the logic expression is x is equal to a or b. Now for this gate, it is the OR gate. Deuxième, c'est qu'on fait the logic diagram. Because the logic diagram will be given, and you will have to find the truth table and the expression. For example, c'est un logic diagram comme, and you will have to find the truth table and the expression. Maintenant, if you are still having difficulty for this case, on a déjà travaillé dans la classe. Si vous avez des difficultés, you can still send me an email or send me a message. I will reply to you. Next, you have the expression. You will be given the expression. You will have to find the logic circuit and the truth table. Par exemple, le cas d'une expression comme A or B and B and C. And based on this expression, you will have to go for a diagram. For example, this is a diagram. You will have to create the diagram based on the logic circuit. Now we are going to do the truth table. Moving on from the truth table, you will have to create the logic circuit, and you can also write the expression. You may also be required to write the expression. Par exemple, c'était un truth table as output 0, 0, 0 and 1. You will be required to produce the symbol or the circuit. For this case, it is only one gate. So you are going to have to find which gate does produce this output. For this case, it is the AND gate that produces this output. Maintenant, quand vous avez ça du voilà, how are you going to find the logic gate that produces this output? Comment procéder? So you have two different ways. La première façon, je vais vous montrer. Let us take a look at the gates that we have. You have the OR gate, the XOR gate, the AND gate, the NOR gate, and the NAND gate. Also you have the NOT gate, which will not be considered in this case. So as for the OR gate, XOR gate and AND gate, it is what is called the basic gates. And as for the NOR gate and the NAND gate, it is what we call the combination gate. C'est quoi the basic gates? They consist of the XOR gate, OR gate and AND gate. It does not consist of merging the NOT gate with another gate. As for the combination gate, it is a gate that has merged two basic gates, which is the OR gate and the NOT gate. In the case of the NAND gate, we have merged the AND gate and the NOT gate. So it is called a combination gate. The truth table for all the gates have been given. Now let us take a look at an example. If you are given a basic truth table, that is two input and you are given the output, you will be required to find the basic gate that correspond to the output. Alors on dirait que I have let us say I have this output, and you will be asked to draw the basic gate here. So how am I going to proceed? The first thing to do is to look at the first output, and the first output is a 0. So if the first output is a 0, I will have to go and check my 5 truth tables to see which one produces a output of 0. You are going to see, for the case of the basic gate, be it the OR gate, the XOR gate and the AND gate, they all produce an output of 0 when A and B is 0. Let us see for the OR gate. When A is 0, B is 0, the output X is 0. For the case of the XOR gate, when A is 0, B is 0, the output is 0. For AND gate, when A is 0, B is 0, the output is 0. For the case of combination gate, when A is 0, B is 0, the output is 1. For NOR gate, when A is 0, B is 0, the output is 1. For NAND gate. Ce qui veut dire que for the combination gate, you are going to see all combination gates produce an output of 1 when A and B are 0. While in the case of the basic gates, the output is always 0 when A and B are 0. So I know from this that this truth table must be referring to a basic gate. It is OR ou bien XOR ou bien AND. Right. So from the first step, we have been able to eradicate the combination gate, and we are going to focus only on the basic gates. Maintenant, to know if it is an OR gate, an XOR gate or the AND gate, we are going to take a look at the second output. The second output produces an output of 1. Alors, you have the two families, the families of OR and AND. For OR gate, the first two results are always different. For AND gate, the first two results is always the same. C'est-à-dire que OR ou bien XOR, they are almost the same. So these two gates, they produce 0, 1, while the AND gate produce 0, 0. If you are going to take a look at the combination gate, c'est la même chose. The NOR gate, which is family of OR, and the NAND gate, which is the family of NAND, AND. So for the NOR gate, you are going to see that they produce different output, while for NAND, which is the family of AND, they produce the same result. So the two outputs are different. So it can only be a family of OR, but not AND, because AND, the two first results should be 0, 0, but it is not the case. It is 0, 1. So given that it is 0, 1, it is 1, a basic gate or XOR AND, and given that it is the second output is different from the first, it can only be OR ou bien XOR. It cannot be AND gate. Now I will have to know if it is OR ou bien XOR. So I am going to jump on to the last. If in the case you get to choose between OR and XOR, you will have to go to the last output, because the difference between OR and XOR lies when A is 1 and B is 1 in the input of 1, 1. So for the case of OR, the output is 1 when both are 1. For the case of XOR, the output is 1 when both are when both are 1, the output is 0 and A and B is 1. So here I have 1, it is going to be the OR gate. So it is not XOR because of the lost result. So here I am going to draw my OR gate. And the expression is A, O, B, or the Boolean expression can be A plus